Okay. Hello, internet. I am back. Um, Let me just pull up good old Excalibur here. Oh my god, I hate that it starts in light mode. Um, okay. So, stream plan. Learn to type. Da da da. That's much too big. Stream plan. So, um, one. This should be a different color. One. We are going to yeah, most of this is like super short. So, uh, finish. Big guide, standard library. Very easy to read, I know. Um, Two. I have a project idea in mind, so I would like to work on that a bit. So, um, learn Zig. I'll just call it netcode. 3 will be chess time. And then 4 will be start project. Wow, I I love my awesome mouse writing. This is awful. Um, but yeah, so that's the plan. Um, I kind of want to just get going, so we'll go here. Zig format provides a way to format data to and from strings. Basic example is creating a formatted string. Must be comp time known. Uh, that's important. So from here, I already have all that stuff. So tests format const string equals try standard format dot alloc print takes a string and args and then returns an error or the string. Test allocator string, which is gonna be this, I guess. And then the actual data, so 9 plus 10 is equal to 19. Defer test allocator dot free string. What is string? Oh, duh, I just made that. I expect equal. Do I have equal? Yeah. U8 string 9 plus 10 is equal to 19. Oh. So if I zig test this, should pass. All 89 passed. Yep. So if I zig run, doesn't print it. Why does it not print it? Writers conveniently have a print method which works similarly. Oh, yeah, because that's just allocating it. I assume that prints it in the, like that's just telling the allocator it's a string. Writers conveniently have a print method which works similarly. Test print var list is equal to standard array list. You want it to be U8 because it's strings. Init test allocator defer list dot the init list dot writer dot print try expect. I'll just copy that. Yeah, this needs to be list. Expected. Huh? Const U8 found array list array. List dot items. I missed that. Oops. $90 passed. Does it actually print it? No. Take a moment to appreciate how you now know from top to bottom how printing Hello World works. Standard debug print works the same, except it writes to standard error and is protected by mutex. So const out file is equal to standard io dot get standard out. Try out file dot writer dot print hello, and then we pass a string. And then that string is going to be world. Oh, my poor little laptop. It's so hot here. So that did print. Wait, why did this print, but these didn't? Uh, it's pretty strange. Try dot print. What if I remove that? Your name is da da da. Read the next line. Hello world. Okay, I don't really understand why that's not printing. But whatever. Um. So print strings here we will use any, which gives us the default formatting. So I assume it just figures that out at comp time and then does that on its own. Const string standard format alloc parent test allocator. Oh boy. I'm just gonna copy that. Um, yeah. For test allocator dot free try expect U8 string do that. So all 92 passed. Yeah, I'm just gonna take that out for now. So why is it not printing? I really feel like it's supposed to be printing. Okay, whatever. Let's create a type with custom formatting by giving it a format function. This function must be marked as public, so standard format can access it. This is used here as curly brace, defaults to array printing over string printing. Huh? Oh, this is used here as curly brace, defaults to array printing over string print. Yeah. Gotcha. That looks really annoying to type. So we have a struct, they have a name, which is a string, birth year, which is an I32, a death year, which can be nothing or an I32. Format function takes a person type, comp time format, puts it as a string. Format options, don't think we've talked about that. Writer, any type. Also not really sure what that does. You want that to be null, or not null, that will return an error or void. So format is discarded, options is discarded. Writer.print that. So we're passing the name, and the birth year in here, and the dash, and then if they have a death year, we're gonna capture that, write it in that, and then write that. Test custom format, so we have a person, Carmack, 1970, not dead, John string, alloc print test allocator string, John. Why are we only passing John here? Does it auto call the format function? I think it will auto call the format function. For the free, expect that Um, so then another person, same stuff. I guess it just auto calls the format function. Also, let's yeah. So it's still not printing. Why? Why do you not print? I really wish this had like expected output. Um, so it's here. Where am I? Here it did write, and writer.print should also write. Is that not? Uh, yeah. Here, let's do a little test. Wrong one. Yeah. So it just doesn't write. That's awesome. Um, Sig. Writer.print not putting to um da, da, da. That's not what I just looked at. Why is this not printing? I do not get it. Zig test output tests results verbose. There's no way. That's so stupid. Okay, we'll just go add 100. Zig test hello world, hello world. Print okay. Again, it's not actually printing this stuff. Summary. F summary does not exist. Enable or disable colored. Module. Linking, that's not what I need. Test options. Debug options. Verbose. Generic instances, I guess. Nope. What? Oh. Zig build summary. No. What the heck? What does Zig build test do? What does Zig build test not work? Why are they? Whatever. I don't need to waste any more time on this. Yeah. Jason. Um, standard JSON dot parse from slice. Uh, hate that. Parsed. The init. Type that again. 93 passed? Yep. Um, Use stringify to turn arbitrary data into a string. So we have a place that has a latitude and longitude. We have a buffer to hold the stuff. Fixed buffer allocator allocates the memory. We have an array list initialized with that memory. Stringify takes the structure. Not really sure what that does. And then string.writer. And then, yeah. Stringify fail out of memory. And that just turns it into a string. So if I go std.debug.print da 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 da. I guess I should clarify that's a string. Invalid type. Right. String.items. Yeah. Okay. Okay, that makes sense. That's that. Da, 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 da. Random numbers. Test. Random numbers for procedural RNG, I would imagine. Rand. Random, yeah. Dot init block. Ba-da-da-dum. Break to block with seed. So that's going to make this PRNG value the seed value. And then rand is equal to PRNG.random. I don't really want to type that. So a is equal to rand as a float, boolean, an int, and then between 0 and 255. And then we're just ignoring them. Does it pass? Yes. Can we print? Um, yank around word and paste. Yank around word and paste. Close enough. Backslash n, and then we want A, B, C, and D. And if we do that again, they should be different. Okay. I guess that one really only makes sense if you have the numbers. Nah. Cryptographically secure random is also available. CryptoRNG. And then this is the same. And then the same. New PRNG using a 64-bit random seed. Random values. I guess I should make a note of that. C and D are equivalent in terms of value assignment. And then the default pseudo random number generator is this. We can now use our knowledge of rand to make a guessing game. Randomly picks a number from 1 to 100 and asks us to guess it. Okay, I'm just going to do that. We can move the threads. .o. Okay. Then guess game.sig. Pub fn main. Okay. It does not have a runtime. It does not manage that for us. We have to create it with a source of entropy. Standard out is going to be equal to standard.io.get standard out dot writer. Let's initialize standard rand default with an unsigned int. Our rand here allows us to from 1 to 100. However, if there's no entropy, we'll always print the same number. Okay. Is it that? Default prng.init. Rand is equal to prng.rand. Random. Then we want to try to print not random num. Rand dot int range. So theoretically, if we zig run this, has no member named random. Huh? Member named rand. How did I just do this? Yeah. std, oh, capital R. $54. And then 54. Yeah. Okay. For good source of entropy with random bytes provided. So we have to use undefined, which coerces to any type. The function posix get random. Where slice is a pointer to a buffer whose length is known at runtime. Because of this, we've used standard memory as bytes to turn our pointer to a U64 slice. Okay. And dot as bytes. Store that in seed. Then do that, and then change inside the brackets. This will be seed. So const target number is equal to rand dot int range at most. We want 1 to 100. So while true, const standard in is equal to standard dot io dot get standard in dot reader. To get, we have to read until we encounter a new line. What is read will need to be copied into a buffer. So we're asking it to allocate up to 8 kilobytes. That seems excessive. Standard heap dot page allocator. That's our delimiter. Do we really need that much? That's kind of insane. Standard dot heap dot page allocator dot free bare line. I don't have to worry about the Windows thing. So next step is to parse a number. It's going to be achieved by passing the buffer to standard format parse int, where the last parameter is the base of the number in the string. We'll want to use catch here in case there's an error, because we are not parsing for the error. Okay, so is equal to standard format dot parse int. We want it to be a U8. We're passing it barrel line, and then 10. What is the base number? Right. Catch error. Switch error. Error dot overflow. In that case, we will standard out dot write all. What? I suddenly forgot how to type. What the heck? Please enter a small positive number. Continue. Or error dot fuck invalid character. We're going to try standard out write all. Please enter a number. Oh, what the heck? That's an expression, so it should need that. And I don't want to type all that because that's basic garbage. So if it's greater than, too big, too small, yep. Wow. Zig run guess game. Found error overflow. What? Ten is too small. 25 is too big. 20 is too small. Yeah. Awesome. Okay. Back to this. Threads. While Zig provides more advanced ways of writing concurrent and parallel code, standard thread is available for making use of operating system threads. Okay. Copy that. Function. Takes nanoseconds in U64. Standard thread sleep. Okay. Still takes that. Nanosecond per second. That's a really weird measurement. Also, why are we multiplying it by 1? Yeah. What is an eye size? I guess I can go here. Signed pointer sized integer. Okay. What do you mean it's never... not what I wanted to do. Sig run sig guide. See what happens. Okay. Sig test. Okay. So that made it wait 1 second. Hash maps. Stacks. Sorting. Iterators. Okay. I'm going to take a little break, get some water and whatnot. Okay. Water secured. The standard library provides an auto hash map, which lets you easily create a hash map type from a key type and a value type. These must be initiated with an allocator. Hash maps. So we have the point again. Actually, place. So this is different. Map is equal to the standard hash map. We want it to be a U32 and point. So I'm assuming the keys are U32. And then we're initializing it with a test allocator, deferring D in it. And then at key 15, whatever, we want to put X1, blah, blah, blah. Yep. So that should work. So here, we're taking the sum, starting it at 0, an iterator. So we're going to iterate over it while there's another spot to look at. You're going to capture that in entry, then add the values, and then see that those are that. Yeah. Fetch puts a value in the hash map, returning a value if there's previously a value for that key. So again, we're just making the map. U8 F32. Oh. Okay. So we're not using the struct anymore. Map.put. So at 255, we're putting 10. And we're going to try to put something in 255 again. So fetch put. Okay, so it gives the 10 and then it puts the 100. Fetch put. Yeah. Checks out. Let's just see what's going on here. Value before fetch put U8. I guess map.get 255. And then da 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 da. After. What do you mean? What do you mean expected after? F32 ignored. I hate my chair. Dot value? Not support field access. What do you mean? Oh, you. No, it's not. Where's my cursor going? I can assure you it's not being ignored. Okay, whatever. I know it works because this works. String hash map is also provided for when you need strings as keys. So we have an enum. So how does this from a key type and a value type? So key type, no. Strings as keys. So if you don't put two, the one you put is the value type, I guess. Uh, so would that still work if I went const u8? Expected one argument, found two. Oh, string hash map. Yeah, it automatically assumes you're gonna have strings as your key. Duh. Okay. String hash map and are just wrappers for hash map. Uh, and then stacks. ArrayList provides method necessary to use it as a stack. Here's an example of creating a list of matched braces. I don't know what that means. String is that. Stack is an array size, list of view size. Pair is equal to open. Nope, struct of open and close, both of view size. We create another array list. For string and index. Character I, if character is equal to open, append I. If character is equal to close, try pairs.append, and then stack pop the open, and then put the close in, and then for pairs.items in index, capture pair and then index, and then equal pair switch. What the heck? Okay, I don't. This one's kind of stupid. Standard library provides for in-place sorting slices. I'm just gonna and get rid of that. Do that. Sort ascending and sort descending. Create a comparison function for the given type at comp time. If non-numerical types should be sorted, the user must provide their own comparison function. Copy. That's not really important. What am I doing? Okay. I ain't gonna lie, this is taking, oh my god, this writing, um, longer than I thought it would. So I'm just gonna cross out that because that's not happening. Um, if I do get that far, that will probably be the order I will do it in. I guess you can't. Hold on. Yeah, because we're. Oh, that one's so long. Yeah, we're almost done that. And then. Yeah, I I do not have time to do this either. So I'll try and do these last three quickly so I can do some chess. Yeah. It's common idiom to have next function with an optional in its return type that may return null to indicate that the iteration is finished. I guess. Da, da. So what's going on here? So text, mem split. On a character from text, and we're splitting on comma space. Um, and just going through the string. Split sequence. That worked. So some iterators have a error optional type return type as opposed to an optional return type. That requires that we unpack the error union before the optional, meaning that the work done to get the next iteration may error. Here's an example of doing this with a loop. Current working directory has to be opened with iterate permissions for the directory iterator to work. That's important. Oh. So iter is trying to open the current directory with the iterator permissions, and then dot iterate. File count is an unsigned pointer sized integer starting at 0 while there's another file. I guess we're going to capture that as entry. If it's a file, we're going to increment file count and then try expect file count greater than 0. This should pass. Yeah. Here, custom iterator, iterate over a slice of strings, yielding the strings which contain a given string. That was a lot of words. I think for this, I'm just gonna capture those. Because, I mean, that stuff is pretty self-explanatory. Except for this. Custom iterator. So we have contains iterator struct. It's going to take strings, which is a constant array. So it's just an array of strings. The needle, which is what we're looking for, which is a string. The index. Next is going to be a pointer to the struct. It will return null or the string. Index is equal to the index. For the strings in index to the end, capture that as string, increment the index. If the index of the string, I'm assuming if that's is equal to the index of the needle, return the string, and then strings is a array of strings. 1, 2, 3. The needle is E. So why are we skipping 2? Oh, because 2 doesn't have E in it, so it won't return the string. Duh. So that should work. Put in a little note here. 2 is checked since doesn't have E, so will be null. So int size dec will be megabytes. Int size bin will be mebibytes, which is basically just maybe will always be power of 2. Megabytes can be 1000 or power of 2. That's really the only distinction as far as my understanding of it goes. It's formatting. And then yeah, I mean, not really any point in grabbing these code snippets because it's just I totally forgot what I was going to say there. Advanced formatting. Format strings actually follow this format where between each pair of square brackets is a parameter you have to replace with something. Follow the format. Oh no, not another table. Um, uh, I guess that's fine. The index of the argument that should be inserted, a type-dependent formatting option, single character used for padding, one of the 3 characters, left, middle, right alignment, the total width of the field in characters, and how many decimals a formatted number should have. I don't have expect equals strings. So the index of the argument. Okay. So index 0 is A. Invalid byte T. Nope, that's not what I want. I want to go from here down 6, let's say. Replace T with, nope. Three, 4. It really doesn't, but okay. Oh, duh. Should have been that. All passed. So fill alignment and width. So here, it's going to fill with the space and right aligned. Here it's going to fill with an underscore, center aligned. Width of 5, width of 6, width of 4. Here's going to fill with exclamation mark. Left aligned. Or right aligned. And then width of 4. And then that's left aligned. Okay. And then finally, using a specifier with precision. So we want it to be 3.14. We're taking the address of B. We're making sure it's a number to 2 decimal places. Then we're putting in 3.1415. Shouldn't this fail because it's a U8 and that's a decimal? Or is it being treated as a string value? I think it's being treated as a string value, yeah. Okay. That's standard library done. I did not want the arrow. And yeah, I have time for a chess game or two. Yeah. Okay. unfortunate that that took so long, but oh well. Uh, yeah, I think it's lechess.org. I love when my chess site is just full of bots. This is awesome. Oh, no, that would be bad. Um, I can do that. If they don't do anything weird. Apparently, they're not going to do anything. Um, yeah, I guess I don't want to do that anymore. Guess I want to bring my rook back. I can bring my queen there so that they move their knight, and then I can move it there. Then I'll have probably checkmate. Oh, Don't want to move my queen there. It's so Jover for this guy. Checkmate. Although I guess if they move their rook, they can move their king. And then it's not, but that's a pretty easy fix. Because I would do that. And then my queen could go there, but that doesn't matter because boom. Wow. A6. That move took almost a minute. Um, yeah, that probably wasn't the best move. Although I guess I wouldn't have been able to move my queen there or there yet, so. And they castle and I do that. Yeah, the knight wasn't really doing anything. So instead of doing that, it probably would have made more sense to do that, but oh well. I guess pretty clean game. Did they even take a piece? Wow. Okay. Yeah. I guess with that, it's time for the stream to be done. As always, if there were any lurkers, thank you for lurking. If not, well, doesn't really matter. And I will see you guys next time.